Hello, welcome. I am going to walk you guys through an example of this Delta Math assignment to kind of show you guys how I would approach a problem like this. Now, you are all going to have a different function to start out with. This one that I am given here is a logarithmic function because remember, it has the word log in it. If I had something with an exponent, it would be an exponential instead. But the ideas that we are looking at here are the same because logs and exponentials are inverses. So we are going to look at the graph first. Okay, because first it starts out with saying plot all of the points of the inverse. So we notice here how it gives us a solid graph, and we see some dots that are highlighted on here. So what I'm going to do is I'm going to look at the points that it gives us. And I'm going to find the inverses. So starting here with this point, right? This is 6, because it went to the right 6, 0. So remember, we always start with the x value first and then the y value second. If I'm trying to find the inverse, I don't know why it doesn't write it right. I'm trying to say inverse. If I'm trying to find the inverse, all I have to do is switch the order of these values. I am not going to make it positive or negative. I am simply going to switch the order. So instead of 6, 0, it is going to be 0, 6. By definition of an inverse, that's all we have to do. It's just that the x and the y values are switched. So I'm going to plot this point. So instead it's 0. So I move to left, right, none. And then I go up 6. So that's 1 point. And then I do the same thing with all the other points. So this one is 2, 1. So I switch it to 1, 2, which is over here. Oh, that's 2, -1. My bad, guys. 2, -1, so I change it to -1, 2. If you mess up like this, all you have to do is click on the point again to get rid of it. So it was -1, 2. Then I'm going to look at the other one. So this one was 0, -2. So I'll change it to -2, 0. And this one is -1, -3. So I'm going to change that to -3, -1. So let me plot these points. -2, 0, -3, -1. All right. Once you have your points graphed, you're going to click this button here that says Draw Graph. If you are right, some more stuff is going to pop up on the bottom. So let's see. Woohoo! So if it's all right, then it's going to graph it, and then this stuff is going to appear on the bottom. Okay, so that's the first part with the graph. Moving on to the second part, the first thing it's asking me is the inverse can be given by this function. So we have to find the inverse of the original function that they give us. And what's nice about that is once I figure it out, I can use Desmos, because Desmos is a lot more interactive than what's on here. I can use Desmos to then help us out for the rest of the problem. So let's start out with our function that they give us here. Ooh. So first things first, I'm going to rewrite it as y equals . So what I want to do here is I want to make it x equals. I want to switch the x and the y. That's always going to be my first step. Okay, so first you're going to want to switch the x and the y. always the first step. After that, we're going to try to solve for y. That is always our steps. Or those are always our steps. So the first thing that I want to get rid of that's the furthest away from y is this minus 3 out here. So I'm going to do plus 3. So I end up with x plus 3 equals log base 2 y plus 2. All right, now the next thing that's furthest away from the log, it's not the plus 2. It's actually this log with the 2. Right? The way that I get rid of log is I have to use an exponential. Now the way that I'm going to do that is I'm going to use the formulas that we talked about a couple of classes ago, and that would be b, and I'm going to color code, so forgive me, it'll take a second. B to the x is equal to a can be transformed to log with a base of b, a equals x. Now, it's not exactly in the same order. Like the stuff of the equal sign is switched like logs on the right side instead of the left side, but it doesn't matter. So I want to write this in exponential form. So if I'm wanting to write it in exponential form, well, first I have to figure out what b is, because that's the first thing that pops up. Here, I see that b in a log is this number on the bottom. So I'm going to start out writing 2. Then for x, this number up here, I see that I can find it by looking on the other side of the equal sign from log. So here I know my exponent is x plus 3. And then equals a. Now a is the part that is right next to the log and the base. So that would be this. Right? So from here, I just continue to get y alone. So like this, I get y outside of the log, outside of being associated with the log. All right. And I still have to continue solving for y, but the last thing that we have is that plus 2. So now I will do minus 2 on both sides. And my final function is y equals 2 exponent of x plus 3, and then minus 2 at the very end. So some of you guys might have variations on this. So you're probably going to see a few different examples like this. In your assignment, there is only 2 problems. But so you might see some differences. Worst case scenario, if the one that you have doesn't look exactly like this and you're freaking out because you want it to look exactly like the problem you want, there is a button on your work that says show examples. And they have several examples that you can look like until you find one that looks exactly like yours. So please utilize the skills around or the tools around you. We also have the videos of the notes where we went through going from an exponential to a logarithmic function. So if you want to see another example like that, you can. If you have any other questions on how to find an inverse specific to your problems, you can always ask me. But let's take a look at the rest of this. So now that I know what this is, I'm just going to put in here what I got. Right? And then it asks about what kind of asymptote it has. If it is horizontal or vertical, all right, horizontal or vertical. If it is x equals or y equals, and then what that number is, what's the range of the function, and luckily it gives us options, and it is increasing or decreasing on its domain, and we have to know what the domain is. So we're going to go to Desmos, and we're going to type this function in there. So it's 2 to the x plus 3 minus 2. This is also a great way of checking that your graph on here looks like your graph on Delta Math. So it does, cool. All right, so the first thing it asks is if it has a horizontal or vertical asymptote. Remember that horizontal, right? Horizontal. I would like to write something, right? Horizontal is side to side. So horizontal is this direction. Vertical is up and down. So when I'm looking at the graph, I'm looking to see, okay, where am I seeing an asymptote? Where am I seeing a straight line? Am I seeing a side-to-side straight line where the graph stops, or am I seeing an up and down line where it stops? So if I'm looking at this graph, I see that it does go flat. I see that one of these numbers stops, and it is stopping side to side. So in this case, I know that whatever the asymptote is, it is horizontal because it's going side to side. That's where it's going flat, side to side. So click horizontal, asymptote. And now I see the number where it stops. It's a y value. Remember, because the second number in our point is the y value. And that value is -2. So here I would put y equals -2. The range, so range now is associated with my y values, how far up and down it goes. So again, I'm just clicking a point on here and dragging. I see that the lowest the y goes, it doesn't go past -2. Right, so my lower value is -2. The highest it goes is, it doesn't look like it's going to stop. So it would go up forever to infinity. So here I would go from -2 to infinity. And then if the graph is increasing or decreasing. So when I'm looking at the shape of the graph, does it look like it starts from low and goes high, or that it starts from up high and goes low? Is it increasing or decreasing? Now here, if I'm going from left to right, it is going up. So I would say that it is increasing. And the domain is how far left and right it goes. So I do the same thing. I click this point and I drag it. And now I'm looking at the first number. So it doesn't look like it's going to be stopping anytime soon. It looks like it just keeps going. So it goes to the left forever. And then when I'm dragging it this way, I see it doesn't stop. It also keeps going. And it also looks like it is not going to stop. Yeah. So for my domain, it is from -infinity to infinity. So you're going to want to check. It is going to be different. If this has a log in it, this is not exactly the same. It is different. Logs have vertical asymptotes at x equals whatever number it stops at x equals. The range for a logarithmic function is the opposite. The range for a logarithmic, so not this type of function. If you have the word log in your inverse function, basically all this stuff is going to be a little bit different. The range and domain is different. It's not exactly the same. For exponential, some of this stuff is going to be familiar. So if your inverse function looks like this, it is going to be pretty similar. If it is logarithmic, it is not. So please keep that in mind. Look at other examples. Let me know if you have any questions. Yay. And that's that. Right? It's just 2 questions. Please show your work on paper and then get that turned in. Thank you.